Hi, my name is Kritika Kumarpan, and I am a technical trainer here at Amazon Web Services. My job is to teach people about AWS services and help them to learn, upskill, and certify in cloud technologies. We're very glad to have you join us today at Awesome Day Online Conference. In Module 4, we are going to take a look at innovation with AWS. We have 5 key components to discuss in this section. We will talk about IoT or Internet of Things on AWS, machine learning, blockchain, AWS Ground Station, and AWS Wavelength. With technology as the enabler of innovation, AWS is your trusted advisor, uniquely positioned to help your organization shift to an operating model optimized for innovation. We will start off with Internet of Things. What is the Internet of Things or IoT? IoT is where a system of integrated devices, such as appliances, watches, features in a car, or even toasters, can be connected to various applications. These connections enable the data to be transferred to and from devices in a bidirectional communication flow over a network. That telemetry data can actually be collected and captured from various embedded sensors, microcontrollers, actuators, processors, and communication hardware that is in the surrounding environment. Automating data collection can reduce the need for human-to-human or human-to-computer interactions. With the number of devices that we have today and billions of IoT devices coming online, there are some inherent challenges with managing large fleets of these things. First of all are the overall updates. We've got devices with firmware, microcontrollers or sensors that we have very lightweight firmware and hardware that we need to be able to keep in sync and updated. Sometimes there are issues with network connectivity. These sensors or devices can be on ships or on various different moving objects where they don't consistently have good internet connections. The second issue could arise is that because these devices are remote, they might not be physically accessible. They may be kind of built into equipments, and we may not be able to readily connect wires to them and be able to update them. And lastly, we might have potentially large fleets of devices in production that we have to manage. How do we manage all the communications to and from the sensors, and maybe between the various different things and sensors? Also, from the analytics standpoint, we might have very low compute power, maybe low spec on device resources. In that case, we may not be able to do calculations or analytics on board on the device. And these devices may also emit very large volumes of streaming data that we need to analyze at a later point. Question is, how do we actually get that data out? How to manage all these devices from the remote standpoint? AWS has IoT services for many of the areas that we just talked about. If you need to potentially take data off from those devices, stream them into a central location, and analyze them, we have solutions like AWS IoT Analytics, IoT Events, and IoT Things Graph. From the standpoint of managing device software, we have free RTOS, IoT Device SDK IoT Greengrass, and IoT Device Tester. And then finally, to actually connect and control these various different devices and provide services that allow us to be able to manage the messaging and communication between these different devices, we have IoT Core, IoT Device Management, and IoT Device Defender. Customers in various industries are using AWS IoT in applications for improving industrial processes. An example would be remote patient health monitoring solutions that enable healthcare providers to remotely monitor the status of a connected sensor. Measuring and collecting field crop and ambient data or key capabilities enabled by IoT solutions. IoT is used for connected vehicle and autonomous driving capabilities too. AWS IoT makes it easy for you to build scalable IoT applications that collect, process, analyze, and act on that data generated by connected home devices without having to manage any infrastructure. AWS IoT can use AWS services as building blocks to set up a secure and powerful IoT deployment. With IoT, you can build solutions that help you respond to events in near real time and reduce your concerns about scale, enabling you to focus more on your core business. As you can see here, AWS IoT is connected to multiple different AWS services, some of which we've talked about already today. AWS Lambda to run your business logic, DynamoDB for your database layer. You can build IoT applications that gather, process, analyze, and act on data generated by connected devices. AWS IoT Greengrass is an Internet of Things, open source edge runtime, and cloud service that helps you build, deploy, and manage IoT applications on your devices. It enables your device to act locally on the data that they generate, run predictions based on machine learning models, filter and aggregate device data, thus saving your time, especially in cases where milliseconds matter. In farm fields across the globe, Bayer Crop Science is planting and harvesting seeds to help farmers improve the global food system. Bayer Crop Science uses AWS IoT for collection, processing, and analysis of seed growing data. This solution captures terabytes of data and enables analysts to pull up dashboards from the collection platform. Using AWS IoT, visibility into field conditions are more readily accessible and data can be analyzed much quicker. Let's now talk about machine learning on AWS. First of all, what is machine learning? Using technology to discover trends and patterns, compute mathematical predictive models based on factual past data, build learning models, and make predictions. Starting off with artificial intelligence. It includes really any technique that enables computers to be able to mimic human intelligence. This could be simple or logic if-then statements, can be programmed by hand too, as it mimics human intelligence. A subset of that is machine learning, which utilizes machines and lots of data to search for patterns in that data, to build logics and models automatically. Essentially, with machine learning, we have a machine that learns based on patterns in that data or come up with its own paradigms and discover its own pattern in that data. Another subset of machine learning is deep learning. This uses a multi-layer approach to perform tasks like speech and image recognition that often require lots and lots of data and many more features. Let's dive a bit into machine learning. Amazon itself is an example of a company that went through a multi-year machine learning journey in order to be a ML-driven company you see today. Amazon had been applying ML in areas such as personalization and supply chain for more than 20 years. ML is an integral part of Amazon. We've improved that original personalization model significantly over time and moved it to other products such as Amazon Prime. We use ML throughout our fulfillment process, including developing a forecast system that can predict the appropriate amount of demand for each product we sell worldwide. In order to deliver on our customer expectation on convenience, cost, and delivery speed, we've developed natural language processing technology to give consumers an entirely new way to interact with technology through Alexa. We've also developed groundbreaking technology with autonomous flight through prime air drones and using robotics in our fulfillment centers to get packages to consumers faster. This was a big culture change for us, but it's something every organization can do. Within AWS, we can see the machine learning and AI services, essentially the stack, as having 3 layers. The top layer that we see here, these AI services, they can be used to integrate pretty much immediately in applications where developers have little experience or time for developing models from scratch. The bottom layer of the stack is for expert machine learning practitioners who work with the framework or at the framework level and are comfortable building, training, tuning, and deploying machine learning models. The middle ML service layer provides features and tooling for developers and machine learning experts to use a more managed option. This increases the speed at which they train, tune, and deploy their machine learning models. Let's go ahead and take a closer look at the middle layer of the ML services with Amazon SageMaker. Traditional machine learning ML development is complex, expensive, time-consuming, and error-prone. Amazon SageMaker removes the difficult work from the process and empowers you to build, train, and deploy ML models quickly. Before SageMaker, doing ML was just too hard for most customers. By making ML easier at low cost, customers can make better use of their data, which is both valuable and differentiating. Amazon SageMaker makes it easy to deploy your trained model in production with a single click so that you can start generating predictions for real-time or batch data. Let's have a look at a use case here. The National Football League has 180 million fans worldwide. They have engaged with the Amazon Machine Learning Solutions Lab. They had a problem where basically they were generating 3+ terabytes of data and over 1,500+ hours of playtime per week. They were gathering lots and lots of data, but needed a solution for real-time stats, for reporters and sport announcers to be able to generate those stats during the game while it's being played. The solution they picked up was something called Next Generation Stats. Live data was streamed to AWS from RFID tags on the players themselves and the ball that was being used in the game. Then, those machine learning models were built within Amazon SageMaker so the predictions could be made in real time. That's a good real-life application of being able to generate that data and report on those metrics for all the fans, the newcasters, and sports announcers to get that information as the game is being played in real time. Next, let's take a look at that top layer, the AI services part of the stack. One example here is Amazon Recognition. It makes it easy to quickly add sophisticated deep learning-based visual search and image classification to your applications. With the Recognition API, you can detect objects, scenes, and faces in images, and search and compare faces. If you want to be able to generate metadata or tags for various photos, let's say to do cataloging or searching or management of those. Being able to understand demographics of, let's say, customers, or maybe sentiment of those customers in store as they're browsing and shopping. Maybe face comparison. If we want to be able to determine if the person that just walked through the hotel door, are they a current guest? Have they stayed here before? Things of that nature. It has various other kinds of facial recognition components as well. Recognition allows us to be able to upload photos and extract data from those photos that is relevant for various different applications. As an example, of object and scene detection, taking a photo and having it essentially tag and identify different objects from within that photo. Here, you can see we have a man and a woman sitting down at a table, looking like maybe they're at a restaurant. It looks like the waiter is holding a pen and a notebook. All the data that we have from that photo, we may want to catalog and then utilize as a way to either search for those photos or potentially use within our machine learning projects. Recognition makes it really easy using detect labels to determine different objects that are within that photo that we provided. With Amazon Recognition, you can easily detect when faces appear in images and videos and get attributes such as gender, age range, eyes open, glasses, facial hair for each. Facial recognition is one of the common forms of biometrics employed across industries for fraud prevention. Do they fit within a certain age range? So that we can maybe enrich our dataset and be able to maybe send them specific targeted ads or promotions based on qualities of the individual. Here we are in the AWS console. Let's search for Amazon Recognition Service and choose that from that list. First, we will look at face comparison. This is the reference face, comparing it with a group picture. Result is similarity of 99.9%. Let's look at another example. From my pictures folder on the laptop, I am uploading two pictures, one by one, to compare. It found a similarity of 99.5% in these two faces, but no similarity with other faces. Let's now look at how recognition helps with facial analysis. I'm uploading a picture again from my laptop, straight away got some results. It is 99.9% sure the picture has a face, appears to be a female, and even the age range. Smiling 80% sure, appears to be happy, clicking on more, eyes are open, mouth is closed. So a complete analysis of facial attributes, including the confidence scores. Now let's take a look at the text in the image. It automatically detects and extracts text in your image, as you can see here. Next up, let's look at blockchain. Blockchain technology is well suited for complex workflows that span multiple organizations. Some of you might be familiar with different implementations of blockchain. Possibly one of the most significant or recent implementations of blockchain is Bitcoin or Ethereum, but blockchain can actually be used in a variety of other applications too. And if you're not familiar with blockchain as a concept here, blockchain makes it possible to build applications where multiple parties may need to exchange transactions, and maybe there isn't a central authority in that situation. Here, we're dealing with the notion of decentralized trust. But today, in order to use blockchain in a variety of different applications, it's actually pretty difficult to get started. Building a scalable blockchain network with existing technologies is complex and hard to manage. There are a couple of things that each of the network members in the blockchain or those who participate in the blockchain needs to do. One is manually provisioning hardware. Installing the software, knowing what is the right version of the software that needs to be implemented, and also keeping those things up to date. Creating and managing certificates for access control to the blockchain. And then configuring network components. None of these are insignificant, especially as something as complex as a blockchain cannot be easily implemented.
A blockchain is a distributed ledger that is decentralized, distributed, and immutable, enabling automated process workflows. Let's look at an example that demonstrates how this technology works by visiting the voting process. Traditionally, people go to a trusted location to cast their vote. They mark their ballots, which are submitted through a centralized, trusted party. It's a system that's been developed over a long period of time. But what if, instead of mailing a ballot or visiting a voting booth, you vote using a private digital voting token that's linked to your identification when you register to vote? With a distributed ledger, voter registration, verification, collection, and tallying can be automated. And it's trusted by everyone because identities are protected with digital signatures. The ledger is shared across multiple parties, and any changes made must be agreed upon by all. Participants can see the history of the immutable ledger, replacing the traditional previous need for a trusted third party. This is just one example of how blockchain technology can transform a common process. So how can building a blockchain on AWS be beneficial? You can build a superior blockchain solution by using AWS APIs and service integrations. Just like with a database, you can use the wide range of AWS capabilities to perform various functions on a blockchain. For example, technically savvy voters could incorporate AWS analytics services to gain insights to what is taking place on a blockchain. They could also create live streaming visualizations of how each group is voting across a geographic area. Give your blockchain superpowers with AWS.
Let's look at some use cases for blockchain. Shipping. Blockchain can be used to ensure the entire history of a ship item as it's moving from one country to another and going through that entire shipping system all the way through delivery, and we can ensure the integrity of that system. From raw sourcing all the way through to delivery, we can independently audit and verify the entire journey there to make sure that the item that was shipped where it originated from, the item that we're receiving with a certain degree of confidence. With blockchain, supply chain companies can document production updates to a single shared ledger, which provides complete data visibility and a single source of truth. Another really big use case here is finance and banking, assuring that the transactions are legitimate. Having a way to basically be able to agree among multiple different parties within a network that those transactions are valid and correct. Let's now see some of the qualities of blockchain that enable those use cases. First, this idea of decentralized trust. We talked about financial institutions, or maybe mortgage lenders, basically being able to agree among multiple different lenders or parties that a certain transaction that happened truly happened. They're able to agree to a sequence of steps or the origination of a loan and various components like that. All of the participants in the blockchain network here are able to agree on what had happened. And importantly, they have the transparency to be able to do that. Shifting over to the benefits here. In terms of the transparency around those transactions that happen, every member of that network is able to participate and have visibility to what transactions have happened and the data behind those. Immutability in terms of the transaction can't be altered in any way. Once it has happened, it is permanent in nature. Auditability is one of the other benefits that we get here. Being able to audit that certain controls were followed and certain regulations were followed. Permissionless, the idea that we don't necessarily need to have certain central authorities to be able to give permission within the network here. Everyone is in agreement or not in agreement based on the consensus model. Now, in order to get this decentralized trust and the benefits that we talked about, And in order to realize those, we need to be able to set up the blockchain. It's actually quite complex to be able to set up a blockchain in terms of standing up the right infrastructure, using the right applications and the right code to be able to do that. One solution to this is the AWS Blockchain Services. AWS Managed Blockchain is a fully managed service that makes it easy to create and manage a scalable blockchain network using popular open source frameworks like Hyperledger Fabric and Ethereum. This is something that makes it a lot easier for multiple parties that want to set up blockchain potentially within an industry, or like I said, peers on the network to be able to set up a blockchain to participate in. A couple of significant features. Fully managed. The idea behind fully managed in this case is that you don't necessarily need to wait weeks and weeks for the blockchain to be built out according to the specification. You can create a blockchain network in a matter of minutes. Open source variety. As you have support for two popular frameworks, Hyperledger Fabric and Ethereum. Decentralized. To democratically govern the network. Don't have one member that is more important than another member or can override or change or mutate the state of certain transactions. And lots of other components of this, but also familiar pay-as-you-go cost structure, only paying for the resources that are being used. And integrated, of course, with other AWS services so that you can really take development on that blockchain much further. Let's look at one example of this being used. Nestlé is a global food and beverage company with more than 2,000 brands and distributions across 189 countries worldwide. They wanted to uncover transparency around its coffee bean supply beyond just the brokers and suppliers. They really wanted to have an understanding of trades of the raw materials and have more visibility into that. They wanted to track every point in supply chain for this premium coffee. They chose AWS Managed Blockchain to basically trace back every single step in the supply chain from the farmer to the grader to the roaster and then the packer. You think about all the steps that go along in that typical process, from actually growing and sourcing all the way through to when those beans are being packed and then eventually sold. This is an excellent use case where you want to understand the supply chain in the case where the largest amount of coffee bean procured around the world. Nestlé and their customers can now track the high-quality single-origin coffee from farmer, logistics, distribution center to customer. Next up, we have AWS Ground Station. Satellites are used for a wide variety of use cases, including weather forecasting, surface imaging, communications, and video broadcast. Sending satellites into space is becoming more and more common and accessible. We're getting more data back from the satellites than ever before. Some real-world use cases and examples of where we can use satellite data are weather forecasting and agriculture. Being able to monitor the crop health and maybe use of water across fields and water levels, commercial food producers can use resources efficiently. Another example is global shipping and anti-piracy. Understanding accurate ship positioning around the world and being able to use satellite imagery and telemetry to do that. Earth observation and fire safety. Maybe helping fire commanders understand what is the lowest heat entry point to fight fires and the most efficient way to do that. Retail forecasting. As simple as it may sound, understanding how many cars are parked in different malls and locations where people shop around the world can help understand how often people are going out to the stores. How much money are they spending within those retail stores? Getting this data back has become much more accessible, but there are still some challenges that remain. Even as it's becoming more common and more accessible to send satellites out to space, the infrastructure required to be able to collect data back is still challenging for governments, universities, and businesses. Today, you must either build your own ground stations and antennas or obtain long-term leases with ground station providers, often in multiple countries, to provide enough opportunities to contact the satellites as they orbit the globe. The actual ground antennas in this case are difficult to maintain, and it requires a high capital expenditure to actually scale up to collect that data. Even if you can get more satellites out into space and retrieve more data, there are still challenges in terms of the actual infrastructure. That is where AWS Ground Station comes in. AWS Ground Station eliminates these problems by delivering a ground station as a service. This enables you to easily control satellite communication. It is a fully managed service that lets you control satellite communications process that data is coming in. Scaling your operations without having to worry about building or managing your ground station infrastructure. Those actual antennas that you need to lease or to buy to retrieve that data makes it a lot easier with the ground station service. It's a fully managed service, so you don't have to worry about the infrastructure and scaling components underneath that. Requires no maintenance, software updates, or application downtime. AWS does all the heavy lifting for smooth and secure operations. Pay-as-you-go pricing, pretty incredible. Having the ability to just pay for the resources as you need them. And if you no longer need them in the future, you can release them and you don't have to pay for them any longer. There is no licensing requirement here. You can scale your satellite communications as your business needs. Another offering is self-service scheduling, which makes it really easy to schedule time to take the data into your AWS environment, and then from there to do the analysis and maybe even take advantage of machine learning like we talked about before based on that data. We get near real-time data delivery, so the data can be analyzed very quickly. Let's go to the AWS Management Console. Now search for Ground Station Service and select it. Here is an overview of how it works. You figure out which ground station that you are going to want to interact with. You identify which satellite you're going to interact with. You set the schedule effectively a contact time when you want the satellite to interact with the chosen ground station when that satellite is going to pass by in close proximity to that ground station. Then each of those ground stations have multiple antennas, so you can simultaneously be downlinking and uplinking. The data connection is through a network that's in an Amazon Virtual Private Cloud, and the data gets downloaded directly into it. So now it's in your AWS infrastructure to store durably and then to do whatever analytics and processing you want. Now we will talk about AWS Wavelength. Let's first discuss a couple of drivers for AWS Wavelength. With the advancement of onboard capabilities for many mobile device sensors, like I mentioned before with IoT video cameras, and many other devices are generating large volumes of data, often needing to either compute or process that data very close to the point of data generation. There's a need to essentially have more infrastructure behind the scenes, ready to be able to process that data locally much more quickly. There's another driver here in terms of 5G and mobile edge computing. 5G proliferation for the next 4 years, it's projected that billions of mobile subscribers are going to be on 5G or 5G-ready equipment. We have new use cases like cloud gaming, video streaming, IoT, connected vehicles, and other applications. And then, finally, mobile edge computing. Certain applications, like games, demand requirements like low latency and local processing on those mobile edge computing devices. These drivers are some of the reasons for a need for a product like AWS Wavelength. AWS Wavelength combines the high bandwidth and ultra-low latency of 5G networks with the AWS services we talked about earlier to let developers innovate and build a new class of applications using those, again, low latency and high bandwidth from 5G. Essentially, we have scalable capacity within the communication service providers, or CSP, within those data centers that are managed and supported by AWS. AWS compute and storage infrastructure is embedded inside the communication service provider mobile network. All the processing and storage can happen much more close to the end user, and again, taking advantage of that low latency for the specific applications. You can then have access to services in the AWS regions. You can use the variety of other AWS services. You can develop applications and deploy them for use with 5G networks globally. A few example use cases for AWS Wavelength. Healthcare is one industry where Wavelength is really making an impact. AI or machine learning solutions for processing the images that are maybe taken from multiple different types of equipment in hospitals, maybe for radiology, and being able to do a real-time diagnosis on very large images or maybe even video that is taken from those machines. Connected vehicles, which we'll see an example of in a moment. Smart factories. Industrial automation applications use ML inference at the edge to detect quality issues on fast-moving assembly lines and trigger actions to remediate the problem. AWS Wavelength enables these applications to be realized without having to use expensive GPU-based servers on the factory floor. The amount of technology enabling vehicular communication system and the degree to which these technologies are interconnected continues to advance at a rapid pace. LG Electronics is using a next-generation CV2X platform on the Verizon 5G network using AWS Wavelength to move data in real time. It uses AWS Wavelength for low latency, high throughput for connected vehicles. You might have autonomous or connected vehicles that need to be able to send large volumes of data, potentially stream it in real time and process that data very, very quickly with low latency and get either decisions or data points back to those vehicles. Over the 5G network, without having to go all the way back to the regions, are excellent use case for something like AWS Wavelength. This concludes Module 4, Innovation with AWS. We hope you found this session helpful with some of the newer innovation areas like IoT, machine learning, blockchain, wavelength, and ground station. Thank you again for attending, and we really appreciate your feedback so that we can better understand the topics and services you would like to know more about. So please do take time to fill out our survey and let us know what you think. Thanks again for watching. Stay tuned for our next and final module.